Hi there. Hi, everyone. I am Arafat. I am from India, and these days I'm living in Canada. So this is not my first time in Wrocław. I've been to Wrocław before, and really like this country, really like this place. Like the difference between me coming here for the last time and this time is all the electric scooters. There's so many of them around the city these days. Um, I have a confession to make. From in the last 24 hours, I have spent around 100 zlotys on the electric scooters. I am still alive, and anybody who doesn't believe that claim can see my bank transactions. Uh, Either way. Also, this is probably the worst time to give a talk because like the barbecue thing is so enticing. Like everybody's like, I want to go there, and I'm just like, yeah, you listen to me. To give you to like let you in a little secret, I kind of am waiting for the barbecue too, so it's fine. Okay, all right, let's get to the talk. So today I'm going to be talking about machine learning using TensorFlow Ruby. And before I start this talk, I'm going to tell you a little bit about myself. So I work in Canada, and I travel all over Canada. I've been to British Columbia and Quebec, Ottawa, everywhere. And this is one of my favorite shots. I really love hiking, kayaking, and all kinds of outdoor sports. So if you're the kind of person who loves those too, tell me something about like Poland and like meet me after, and let me know about like how sort of the outdoor sports scene is here. So sorry, yeah. So yeah, so these days I'm working at Shopify, and Shopify is one of the largest e-commerce companies in the world. They've done so much for Ruby and the Ruby on Rails community. So I'm super excited to be working there, and yeah, so that's kind of my background. So I'm going to be talking about TensorFlow Ruby, and the reason I'm going to be talking about it is because I wrote it. So, show of hands, does anybody know what TensorFlow is, or just by any chance, that's cool. Damn, that's nice to know. So, like, as time goes on, like, I ask this question at all my conferences, and like, more people are coming up with their hands as time goes on. That's good to know. Yeah, okay, show of hands. How many of you guys use TensorFlow or machine learning in like your companies, in your personal work? Just like, that's it? Like, you guys don't know machine learning? Are you even developers? But yeah, so yeah, we use it too, and yeah, so what TensorFlow is like it is the largest machine learning library in the world, and it's a library for numerical computation of data flow graphs. So if you look at this graph that you're seeing here right now, what it is like you see this thing called softmax, softx linear, stuff like that. What these things are, these are computation operations. And all these lines, these arrows that you're seeing here, these are flow of data. So flow of data in TensorFlow is essentially flow of tensors, and tensors are generalized n-dimensional matrices. So for example, a one-dimensional matrix would be an array, a two-dimensional matrix would be, say, a normal matrix, and an n-dimensional matrix would be something that is generally what we use in TensorFlow. And since all these data is flowing and you're applying mathematical operations on it, the name TensorFlow kind of makes sense if you look at it that way. So originally, this whole library, it was just an internal thing at Google. And was just used primarily for deep learning and neural networks research, and that was pretty much the goal. But in 2015, Google decided that, hey, you know what? This is something that could be used for very general purpose cases, right? Like for all kinds of machine learning needs. So Google decided to open source it. So with the start of this talk, I have some good news and some bad news. So the good news is that this is a very powerful toolkit. It can do so much for you, but the bad news is if you don't know what you're doing with it, it might not be that useful for you. It's a big enough library to be considered a language in and of itself. So there's that. And the other argument about it is that TensorFlow is essentially for everyone. It is for musicians, it's for pianists, it's for artists, it's for people who work in linguistics, it's for all kinds of people. So there's really nothing holding us back, especially because we're developers, from using it. And it's also an open source platform, so pretty much everything essential, everything that you need is pretty much open source. I can't say about the entirety of it, but from my perspective and based on what I know, it seems pretty nice. Can you hear me? Okay, all right, good. So it's very fast, very flexible, and always production ready. So you can easily try things out, make your models and stuff, and then it will easily be transformed to a production model that works really well with Google Cloud. So the thing about TensorFlow is that because it comes from Google, a lot of things relating to TensorFlow are very closely coupled with Google Cloud. It's not that bad because it's it's decent enough to work just as well for any of your companies in production. So let me give you just a little bit of a timeline. And the reason I'm giving you this timeline, if you look at this timeline, it says like 2015 to 2016, and that's like way too many years ago. The reason I'm giving you this timeline, not the actual existing timeline, is basically because this is kind of how I got into this and kind of how I was involved. And that is like, I will only tell you things that I was involved in, basically. So in November 2015, Google decided that, hey, release it to the public, release it to the society. And that's why the version was called 0.5, because they had, a few other things internally before. Then they added the support for GPUs in December 2015. So if you if you notice carefully, like somewhere around those times, there was a very interesting trend in the pricing of GPUs. They were like fluctuating really well, like sometimes going high, low, whatnot. And part of it had to do with Bitcoin mining. Part of it had to do with the machine learning explosion. So many people just like hogged all the GPUs, and the prices just went crazy either way. So there's that. Then they added the TensorFlow serving in February 2016. TensorFlow serving is this thing that helps you make really interesting production models. And then they added distributed TensorFlow. So distributed TensorFlow works well with distributed systems like Kubernetes and scaling them really well. Then they added Mac GPU support, iOS support. Then they added TensorFlow Slim. So TensorFlow Slim is this thing which does computation in real time using TensorFlow using machine learning models. For example, you can take your Android right now and download an app, and that would do real-time image recognition based on this platform. Then after adding TensorFlow Sim in October 2016, they added the HDFS and CUDA support. And finally, they added the TensorBoard embedding visualizer. So now this is sort of a really interesting project, and I'm kind of excited about it. So I'll show you what it is, and I'll show you how sort of I got involved in it. So the other thing is like TensorFlow supports many platforms. While all of this was happening, they added support for so many platforms like CPUs, GPUs, Android, iOS, and something even as I wouldn't want to call it weak, but just like less computationally powerful, like Raspberry Pi. It even works on that, and even TPUs. So okay, show of hands. Does anybody know what TPUs are? Ever heard of it? Good. So there's one person. Oh, there's more. Okay. Yeah, so TPUs are these things. TPUs are these very like case-specific solution of machine learning needs, and it's kind of like a GPU, but it's specifically designed to perform machine learning operations really fast and really efficiently. So when it works in the cloud on a scale of like thousands of like cloud resources and stuff, it's very efficient energy-wise, and it's very fast. But the unfortunate thing about TPUs is that you can't buy them off of a store and install it in your computer. That's not how it works. You can right now, to the best of my knowledge, only use it with Google Cloud. But if you have someone who has that kind of needs, you might want to look into TPU. So all right, all of this is great, but like, where do I fit in this, right? This is nice. So my journey into this tool involves this thing that I used, and that was called TensorBoard. So what is TensorBoard? So TensorBoard is kind of like Datadog, but for machine learning. So it's like a very cool and very descriptive visualization tool for all kinds of machine learning models. So for example, sometimes we all work in data-driven organizations, and sometimes, let's say you have to make an argument that you have got 3-4 models, and you want to be able to convince your organization that among these 3-4 models, the one that this X model is better than the rest of them, and you want to be able to do that using visual metrics. So in that case, it helps you really well. You want to be able to understand the model really well. So to do that, you can view the data flow graph. I'll show you what the data flow graph looks like. Just wait a while, I'll just show you. And finally, like generally plotting any sort of quantitative metrics. So For example, how the parameters would vary as you would perform different iterations on your machine learning model. So let's take a problem, one of the problems that I did and that enticed me. So if you look at this one looks like you see tensor 1, tensor 2 addition. So this is sort of a data flow graph of a rather simple computation, something as simple as just adding two tensors. You take tensor 1, you take tensor 2, you add it, and then you get a result. This is a simple data flow graph. This, on the other hand, is a different example. This is the example that I was kind of talking about before. So if you look at the bottom, you would see like kind of like this chart of like different colors and some going up faster than the others. And this is basically how the parameters would vary as different iterations go on. And this could also be used to figure out that if you were hypothetically using multiple models, which one of them is better than the other one. So let's talk about a very specific problem of the MNIST data set. So what the MNIST data set is basically, it's a data set of handwritten digits. So if you see this image right now, you see all these numbers like 1, 2, 3, 4, all these numbers. And the thing about email is like, everyone has a different handwriting. Everyone writes numbers differently. Some people write it in a decent enough fashion. Some people write it in a way that they can't read it themselves. But either way, the computer's job with this problem is that it wants to look at this individual like photo in this image, like let's say a number 4. It wants to look at the individual image of a number, and then it wants to label that image with a corresponding number. So to solve this problem, we use neural networks, and the idea behind neural networks comes from neurons. Neurons are this thing we study in biology. We all hate biology. That's probably why we're developers, but either way, so the idea behind neural networks looks mathematically kind of like this. This is an activation function, and you make it more and more complicated, and that's when you get a proper neural network. So let me show you how it actually looks. So wait. Yeah. Okay. Yeah. Okay. So the first thing that TensorBoard does is that if you're trying like if you notice there's LR1E03 convo 1 FC2. This is basically if you were to have a model with different parameters. Wait. Let's see if I can make this. Yeah. Okay. Yeah. So this basically shows like if you were to have a model with different parameters, how would the accuracy vary as you try it on different iterations. On the x-axis, you see the different iterations. On the y-axis, you see the accuracy in like 0 to 1, and it improves as the iterations go on. So that is one use of the TensorBoard. This was pretty cool. So now the other thing that you can do is, wait, yeah. So we can do with this, what we can do with this data set is we can do principal component analysis. Wait, let me, sorry. Yeah, so we can do principal component analysis of all these images. What exactly is principal component analysis? What it does is that it takes each and individual picture of a number, let's say 3, 4, 5. So let's take a 2, for example, here. It takes the individual picture of a number, and it applies a neural network model on it, and it maps it to a 3D manifold. Basically, you take a number, you take an image, you map it to a point in XYZ axis, right? So once you do that, you sort of see these numbers. Let me make it more clear by coloring them. So by applying the PCA algorithm, you would notice that all these numbers have now some space in the 3D manifold. And if you notice clearly, like a lot of numbers which are identical are kind of together. So you would see like all kind of 4s are together, all kinds of 1s are kind of together, all kinds of 7s are kind of together. But every once in a while, things are kind of intermingled. And you can sort of zoom in and see which ones is where. But now we want to apply a really more powerful operation on it, and that's called t-SNE. So what t-SNE does is that it would take this image and do this. Let's try this out. So you notice how, like, if you notice at the bottom, there's an iterations counter that is increasing. I hope you can see it. There's an iterations counter at the bottom that is increasing. So as the time goes on, this model is training more, and iterations are increasing. So after applying t-SNE, you notice that all the kind of 1s get clustered together, all the 4s kind of get clustered together, all the 7s are kind of together. And every once in a while, there's a mistake here too. So for example, take this for example. This is a 4. and this 4 is with a bunch of 1s. It probably doesn't belong there, but it's kind of like, it kind of looks like a 1 too, so it's maybe the 1ES4. So there's always mistakes, but you can notice like how this tool was really like descriptive visually, and you can use something like this for your own, for your own purposes. So let's come back to the talk. So all of this is great, right? All of this is great. This visuals and stuff. It's kind of like Woovie. It's kind of like a motivational tech talk, whatever. But why am I doing this? What's the point? What is my role in this here? You could very well have done this yourself. See, the thing is, like, where I come into picture is that, let's dial it back to the timeline. So in the summer of 2017, I was in the university. I was studying there, and like every college student, I was broke, I was aimless and miserable. And I wanted to do something. I wanted to do something great. I wanted to make something of myself. And it seemed to me that if you want to be cool, you want to do something really high impact. And I wanted to do like really awesome shit. And it's like I was kind of very, how do I say it? Eager to do something cool. So then an opportunity came along. And this opportunity is about language bindings for TensorFlow. So you see what happened back then was I saw the TensorFlow project being released. I was doing all these things. I was having fun with these models. And I saw the language bindings project come along. So this is sort of one of the GitHub issues. It's the issue for the Go API. Golang is a very interesting language developed by Google. And I've spoken at Golang conferences before for other stuff. So this is one of the issues of Golang. And you can notice like how this person has got a lot of low reacts and stuff for their issue. There were hundreds of comments on this issue. This is another issue. This is for the Java interface for TensorFlow. And this is another issue for the language that we all love, Ruby. So you notice that, like, OK, this is an interesting project for TensorFlow. But the problem with this project was it was just in Python. The whole thing, everything we saw right now, everything we've seen till yet, it's all in Python. And nobody else can use it in any other way. So you got these issues where people are making a proposal. Hey, wouldn't it be a nice idea if you were to have this in other languages like Ruby, Java, and Go? So, but the core devs had other plans back then, and that was very unfortunate. So while all these issues were very heavy, they were getting hundreds of responses from the community, the core devs were basically saying, I am sorry, we have other plans, and we can't work on this right now. And from their perspective, they were right. Maybe they did have other plans. Maybe they did have better things to do. So working on language bindings wasn't exactly their goal. But then someone had to do it. And in this very case, it had to be me. So how did I build it? So the nuances of how I build it and how I transformed this like really massive library into something in Ruby, it's kind of like there's many nuances, so I can't talk about all of it. But like I can give you a few things that are really, really nice. And these will help you sort of in your work as a software developer. And in like these are ideas that are general enough that like even if you want nothing to do with this, these ideas will help you in your own life as a software developer. So the very first thing is the TensorFlow C API. So you see we have got this massive library. This library has so much code, it's basically kind of like a language. And I'm here ambitious and stupid kind of also trying to convert it into another language. So what I did was I looked at this whole language and I realized that at the core, there's some C and C API, C++ code. And that code at the core, that was basically the running engine of the entire library. It's like the library is a car and the engine is the C++ code. So what I did was I looked at the base C++ code and I abstracted out a few bare minimum functions that are just like the absolute minimum required to work with the whole library. And I missed a few things, I added a few extra things, but basically I looked at the whole code and I took out a few C APIs. So if I did take out the C API out of the code, I still have a C API. I'm not using Ruby now. So then the question comes, how do you use Ruby with something in C and C++? That's kind of hard. And this is kind of like, I mean, I'm sure there's many smart, intelligent people here who would say, this is a stupid thing to do, but I wanted to do it, so I did it. And I also wanted to be cool, so I did it. OK, so I had a few options to do this. One was Swig, one was Rice, one was FFI, and Ruby inline. I did a very sort of thoughtful analysis, and for my case, I had to use Swig. I'll give you an example of what Swig is. So Swig is basically a software development tool that connects programs written in C, C++ with a variety of other high-level languages like Java, Python, and other languages. It basically takes a core of C, C++ programs, and then using your other languages of your choice, you can make calls to it. And in order to work for it, it requires an interface file. An interface file is sort of a glue that is between the original code in the C language and your required code in Ruby and Python or whatever. So on the right, the thing that you see on the right, that is an interface file. Wait. So a simple example, let me show you something of that I made. Okay. So apologize for the badly written code, but okay, this is C and this is C++, sorry. So this code that you're seeing here, it's a rather simple example. You have a class of square, and you initialize it with two variables. You calculate the area of the class square, and you calculate the perimeter of the class square. Then you have another function that is called the Fibonacci function. What this does is that it uses a modular exponentiation to calculate a Fibonacci number really, really fast. It works logarithmically. I think it's one of the faster implementations of Fibonacci, but let's leave that. But basically, the idea is this code is in C++, and we're using Ruby. So how would this look like when we call it from Ruby? Wait, sorry. So if you notice, if you use Swig and if you set the interface file in the correct fashion, you could example square.new, and then you initializing basically the object of square class. And this is actually interfacing with the C++ code. Then you can calculate the area. That is the C function, the C++ function. It's making a call to that. And in a similar fashion, you can directly make a call to a C++ function like example.Fibonacci12, calculates the 12th Fibonacci number, making a direct call to the C++ API. But it looks like a hybrid between Ruby and C++. And so you can notice, like, if you sort of just look at this repository and just look at these examples, you realize that a lot of you can basically write Ruby code that is internally is closely coupled with C, C++. Is it a wise thing to do? Definitely not. I would not recommend it. I'm just saying I did this. So that was Swig. Now, what's the other thing? The other thing was protocol buffers. That's the last thing about how I built the library. So the thing about these language bindings is that you've got a language binding in Ruby, you've got one in Python, you've got Go, Java, so many languages. And then it becomes very confusing. How do these things tie up, right? If you write something in Python, how would you use it in Go? If you write something in Ruby, how would you use it in, say, Java? How would you couple all of these together? So the way to do it, in this case for TensorFlow, was protocol buffers. And the reason I would recommend that you use protocol buffers is like they have a very specific use case. So protocol buffers are basically a language-neutral, platform-neutral, data serializing mechanism. So you can really serialize all kinds of data with it. And the way it works in TensorFlow is that every time you write something in TensorFlow, it makes a data flow graph. And in order to save that data flow graph, it does it in a platform-neutral format. And that platform-neutral format, in this case, happens to be protocol buffers. So you could write something in Ruby, you can save that model in protocol buffers, and then you can run the exact model in Python, and vice versa. So this is kind of how it looks like. So basically on the absolute left, you would see a message object, and it has all kinds of, you can have all kinds of fields in it. You can have a string field, integer field. You can even have another object as a field. And basically, a protocol buffer is like, it kind of is like JSON and XML. But then the question comes, why don't we use XML or JSON or something like that? And the reason is that because protocol buffers are much simpler, and they're 3 to 10 times smaller in terms of size. Like if you actually make files, you would realize, oh, this is much smaller. And it's also much faster and really leaves very little room for ambiguity. So that's probably why protocol buffers uses it. The other argument is basically a Google-centric argument, where you would say that Google invented it, used it in a lot of projects. So in that sense, too, it kind of makes sense. Okay, so now that we're done with that, let me show you the actual repository. Like, let me show you how it actually looks like, and let me walk you through the repository that I made and how its classes look like. What I'm gonna do here is that I'm gonna do something really simple. I'll take two tensors. Take for now, just consider a tensor to be a matrix, and we'll try to add these two tensors. And I know this is just something as simple as just adding two tensors, but it's gonna get really complicated. If you don't follow through, that's fine. I've written blog posts about it. I've written so much about it. So it's like, but try to give this a thought. And it's convoluted, but it sort of is trying to prove a point. So the first thing we do is we make a tensor. A tensor is a mathematical object that is more general than a vector, and it's represented by an array of components that are functions of the coordinates of a space. This is basically the mathematical definition of it. Okay, looking at this picture, does anybody know specifically what this image is? Like, exactly what this is? Like, you see these signs here. Anybody study physics at school? So this is like a stress tensor. This is a stress tensor, basically. So yeah, when you have like forces in mechanics, if you studied mechanical engineering or something, you would use a stress tensor all the time. In this case, it's different. So either way, so we initialize a new object of the tensor class. This object has the dimensions of 2 cross 3 cross 3, and it has a rank of 3, and is an element type of integer. Then we perform an operation on these tensors. So these operations, if you remember, I showed you a few data flow graphs. Okay, wait, I actually didn't show you the data flow graphs. Wait, so yeah, so this is basically a data flow graph. And what this is like basically a high-level abstraction of all the things that you can do in your machine learning operation. So if you click on something, say FC2, it will show you all the internals of like the internal implementation. You click on something, say B+, it will open up. So you can go on and on and on. It's basically like a labyrinth, and it's sort of a much better way to look at the whole model. And if you look at these individual things, these are operations. So when I talk about operations, what I'm saying is like operation class refers to any kind of mathematical operation that you will apply on a tensor. It takes 0 or more tensors as input. It gives 0 or more tensors as output. And then I have the operation specification class. So what the operation specification class, what it does is that in this case, it determines the determinant of a matrix. It could do other stuff too. Then I have a placeholder class. Placeholder is kind of a weird midway between a tensor and an operation class. Basically, it kind of takes in a tensor as an input for performing any kind of operations on tensors. And then have a session class. So what the session class does is that it takes this whole graph. So you look at this whole graph, right? It would take any of the whole graphs, and you pass it to a session, and will run that whole model and graph in a session. So that's the role of the session class. So let's look at the final simple example. So at the top, you see I'm requiring the library. Then I initialize the graph. I initialize the objects for tensor 1, tensor 2. I put these tensors in the placeholder 1 and placeholder 2. Then I specify the operation in the offset class. The offset class is addition of tensors, so I'm adding placeholder 1 and placeholder 2. Basically, I'm adding tensor 1 and tensor 2. Then I put these in a session and run that session. And when I do run that session, I get the result of the addition of these two tensors. So you can sort of look at the matrices, the two matrices at the top, like tensor 1 and tensor 2, the matrix for that, and look at the comment at the bottom. That is the addition. It actually did work out. So this is sort of a very complicated way to do things. Essentially, what we wanted to do was we wanted to take tensor 1, we wanted to take tensor 2, and we just wanted to add it. But the reason I'm showing you this example is because even though this code looks very Ruby-like, internally it's all working with a TensorFlow C API. So it's completely working in C, essentially. And it just looks Ruby-like at the top. And this operation could, in and of itself, replace any other kind of matrix operation. It could replace matrix inversion. It could replace matrix multiplication. And you can build as many levels of abstractions as you want on top of this. Basically, the limitation is just like your time and energy. So let's do some kind of an interesting problem, right? So I built a TensorFlow Ruby API, and as the problem with all kinds of language bindings is that while they're nice, they're always very limited in many ways, right? They have to be. That sort of is, the real life. So if you look at the example that I previously showed you, it was just adding two tensors, and even then it was rather complicated. So I'll show you another example here, and this would be running a model that was trained in Python, and I'll try to run it in Ruby and see how it goes. So the problem that we're going to be talking about is the ImageNet problem. So ImageNet is basically a competition for visual algorithms. It's basically like a benchmark for how good your algorithms for detecting and identifying stuff are. So basically, let's say you take a picture of a box or a car. You have to have an algorithm that detects that it is a car or a box or something. And what this competition is about is like all these people, individuals, and companies will participate in a competition to build the best image recognition model. And in this case, like Google itself also participated in this competition. And what Google did was like they performed really well, and then they open sourced their code. They open sourced their code in TensorFlow. So we're going to run the code for ImageNet model. So this the model that we're going to run is Inception v3, and it's a very standardized model for computer vision learning. So if you wanna learn about it, like feel free to read research papers. Feel free to explore as much as you can. I myself have limited understanding of it, but I tried to run it on our code. So the steps that we are going to be doing here is that we have the serialized representation of Google's model from Python in a protocol buffer file. We're going to create a session to execute operations on that graph from the protocol buffer files. And then we will convert an image file to a tensor, and then provide it as an input to the session run. And then execute the session to print out the labels with the highest priority. This kind of sounds weird, but basically, long story short, what I'm going to do is I'm going to show you what happens when you take an image and you run image recognition on it in TensorFlow Ruby, and then you get some results. So I want to show you how those results looks like. So this is something that we all love. This is a puppy, and we all love it. So I really like this image, and I wanted to run the image recognition model on it. So I did. So here are the results. This is a golden retriever with 85% accuracy. And these are the results that I got when I was using like TensorFlow Ruby. You're very welcome to try it. I've written a blog post about this entire thing. So read about it. It's also Great Pyrenees. I don't know what breed that is. That it says that this is Great Pyrenees with 7.8% accuracy, and then other breeds are going down on the accuracy ratio. So okay, puppies are cool. But okay, let's come back to the city too. So I've been to Wrocław before, and I like this city. I like taking pictures and stuff. So one of the places that I've been to is Grunwaldzki Bridge. I don't know how to pronounce it. This is a royalty-free image of their bridge. And I took this image, and I tried to run the model on this image too. So yeah, so it says that it is a suspension bridge with 89% accuracy. It says that it is a pyre with 0.2% accuracy. I don't know what a pyre means, but you can see that the model performs really well on a well-shot image. But it doesn't always perform well. This is another image of the city center in Christmas. It's very similar to a picture that I took. The difference between this picture and mine is that I'm not in this one. But yeah, so I tried to run the model on this one too. And I'm sure that this is sort of a complicated image enough that it shouldn't perform the best. So it says that it's a stupa or taupe. So stupa, I can't exactly describe what a stupa is, but stupa is kind of like ancient monuments and stuff. It says that it is a stupa with a 30%. I don't think that's very accurate. It says that it's a palace with 23% accuracy. So look at this image. It has so many things that the model essentially does not perform well. It just looks at these small nuances of the image and says that, oh, this is what it is. So obviously, there's room for improvement. There's room for ambiguity. But that is the price you have to pay when you do machine learning. So that's one of the models that I'm done with for TensorFlow Ruby. And I would encourage you that you try this and any other model. You can train anything else in Python, and then you can run it in Ruby code just by saving it in protocol buffer. So the learning resources for it is my own website page. So if you want to be able to access this library really easily, just Google TensorFlow Ruby, and you'll be redirected to this page. That would be like there would be a whole tutorial on the TensorFlow website, and lastly there would also be a TensorFlow Dev Summit. So TensorFlow Dev Summit is basically this thing which is like when Google realized that, oh shit, this is going so big, and there were like so many people who were obsessed with it, that they started a whole conference just for TensorFlow, and it's just like the pioneers of machine learning come into that conference and talk about their work and their new improvements in TensorFlow. So I really wanted to go there. It's in San Francisco, but like I was a student at the university and I had so much other stuff to do, so I couldn't go there. Hopefully I'll go there someday. So I would recommend that you watch videos from this place. Also, lastly, the most important thing, I just wanted to mention like how grateful I am to the Ruby community. So if you, in this page, like my project was trending on GitHub because I met and I talked to and I emailed so many people from the Ruby community in open source, and it was even trending on Reddit for a couple of days. The thing I'm trying to say is that like I have met so many people in Ruby community who have been so nice to me and who have been so helpful to me that it's sort of I've come to a point where I've lost count of how many people I have to thank and how many people I need to be grateful for. Few of them, or at least one of them, is actually here. I wouldn't take his name because, yeah, privacy stuff. But I'm very grateful to the Ruby community, and I'm very thankful to all the people who have helped. For working on this project, Scientific Ruby Association, that is one of the associations that I'm a member of. They have helped a lot. Somatic.io, they provided some funding for it, so they were nice people. And Ruby Association also, they provide some funding for it, so thanks to them. And thanks to everyone. Thank you so much. Thank you for coming here.
Any questions?
Hello.
Yeah, hi there.
Thanks a lot for the talk. It was great, especially showing the visualization of T, S, and E. It's great, right?
Yeah, it's awesome.
I would say it's almost like a porn for the data scientists.
Yeah.
Okay, so basically 2 questions. This TensorFlow RB is not a Ruby gem, right?
It is, like, it's not on Ruby Gems, but it is a Ruby gem, if that makes sense. Like, it's not on rubygems.org, but it is a Ruby gem.
Yeah, right. Because
it's super hard to install it.
Mm-hmm.
It is, like, that is sort of kind of a bummer. Like, I mean, we tried to make, like, Docker images and stuff, and I'm just so, like, it's hard to, I have a long install script for it. So, yeah, I apologize for this, mate.
Yeah, sure. So the first question is, I observed some TensorFlow RB gem before, and it was only a port from Ruby to Python. So the performance of that was pretty poor, I think.
Okay.
And I think that project is something else because it links
that is different. Yeah.
Ruby with C API. The first question is, why C API, not Python API?
Well, it comes down to the possibility of actually being able to do something. So the thing is, I'll just give you a general answer that if you want to try to run something from Python in Ruby, it's probably going to be really hard. It's probably going to be really hard. I don't have a decent answer for this. And the other thing that I think in the case of my project was that, like, if you look at this library called like Swig, you notice like how even though it's Ruby code, it's so closely coupled with C and C++ that it works so well. Swig is so well developed for having anything else being able to work with C. And for Python, we have like CPython, so Python works well with C and C++ and stuff. But I think for me, it was just about the ability to actually be able to do something more than anything else.
Okay, yeah, makes sense. The second question is, we are all waiting for TensorFlow version 2 release.
Okay, isn't there like a beta version already?
For now, version 2 is some beta version.
Yeah,
I would say.
Yeah.
And yeah, I'm waiting for the version 2 more than for Christmas.
Yeah, hopefully.
Yeah, the question is, within you're using C API, and releasing the second version of TensorFlow would be really, it would have a really huge impact on using TensorFlow because it has some keras interfaces and some other improvements. The question is your gem would be up to date with the second to the
Okay,
TensorFlow
this is
version?
like this is kind of a bummer. Okay, so look, guys, let's be honest here. When I started this project, I was at the university and I had an infinite amount of time. Now I have a job, and I'm not a good person, so I don't communicate that much to the community. So I might not be able to give it that much amount of time to be able to work on the project. And yeah, so it might not be as updated as it should be.
So maybe a request for some open source community. Maybe someone could help you with the releasing the changes with the version 2 of TensorFlow.
Okay, I'll make a post on Reddit. Thank you.
Okay, I think I could help. For
Okay,
example,
thank you. Oh yeah, for sure. You're well welcome. Seriously, like if you Google like it's so easy to find my email. Anybody can email me. Like you can even send me cat gifs on my email. That's fine. So like I'm always up for like emailing anything. So like you can email me and I'll help you contribute and do more for this project.
we can take a photo afterwards and I can share your email.
Okay. Okay.
Okay,
Cool.
thanks a lot.
Okay.
Hi, thanks for the talk.
Okay.
Do you use this TensorFlow at your work at
No.
Shopify?
No, not me. Other people do. I'm not a data scientist. I'm a backend developer, so I do not use it because I work primarily in Rails right now.
Okay, thanks.